All right, so um, if you have this is this is something you have to know. If you have a delta, right? Uh, your your phase voltage here, right? Your phase voltage here is equal to your line voltage here. So this would be like the power line here, here, here. Let's call this A phase, B phase, C phase, whatever. So this phase voltage here, this phase, the voltage that is between this and this is equal to this and this. So your phase voltage is equal to your line voltage. That's a delta system, right? But your current, the current that's flowing through here, call that your phase current. Okay, and then you got your line current, right? Okay, you got some current coming here and some current coming from the other phase, so they're not equal. So your line current is bigger than this, right? Because you got some current coming from here. So 1.73 times your phase current is equal to line current. Okay, but when you have like, okay, so let me show you what Y system is, right? So you got your Y system, right? And then you got your phase voltage, and then you got your line voltage. You see how this case here, your let's call this A phase, B phase, C phase. You got the neutral here, but anyhow, you see how this voltage between phase to phase is not equal to this because you got some voltage from here. So your line voltage is bigger than just this because you got also voltage here. So your line voltage is 1.73 times your phase voltage. But look at delta. Your phase voltage is equal to your line voltage, right? So this is the Y system. This is the delta. But your let's say your current, your phase current is the same. See that? It's only coming through one, right? In delta there's two different paths, so this is the line current is bigger than your phase current. But on your Y system, your line current is equal to your phase current. And if you get confused which is which, draw it out. You could see that the current right here, your line current, is bigger than your phase because there's two coming together, and then your voltage, your phase voltage is equal to your line voltage. But look at your Y. Your Y phase voltage is right here, but you got also another one right here, right? This is coming from A and this is coming from C. So this voltage right here is obviously bigger than what you got only here. So that's how you kind of backtrack and figure it out. But anyhow, so when you got a system, when you have a transformer, you know, that's rated 2400/4160, okay, whatever voltage that you put on the primary, it's got to be the same in order to, let's say the secondary is rated at 120/240, right? So this voltage, whether you hook it up Y or delta, okay, it's gotta produce 2400 here. Okay, so if the Y system is 4160, right? If it's delta, we just hook it up phase to phase 2400. Okay, the coil's happy, it gets 2400, boom, and it produces 120/240. Well, how is it that when we hook it up 4 kV that it produces the same 120/240 on the secondary side? Well, on a Y system 4160, on a Y system, yeah, it's 4160 here. But when you hook it up on your CAN, when you hook it up Y, from here to here, okay, is not 4160. From here to here is going to be 2400. You get that? So once again, when the transformer is rated at 2400/4160, it's still got to get 2400 in that primary coil. So people be scratching their head, well, how come we hook it up to 4160 and we still get 12240? Well, if you hook it up Y 4160, this voltage drop from here to here is going to be 2400 because of this right here, because of this. Okay, so your line voltage right here, your line voltage is 4160, right? But your phase voltage, this thing, your phase voltage is 2400. And when you hook this up, when you hook up your primary into your CAN, Y, if you hook it up Y, okay, here's your CAN, your X1 bushing goes there, X2 bushing goes there, is going to be phase voltage, right? Which is what? Phase voltage right here, which is 2400. That's why that CAN is going to produce still 120 and 240. Same thing when you hook it up delta to 2400, your phase voltage is 2400, and when you hook up your CAN, right, it's phase to phase, right? So your primary voltage is still getting 2400. Down here too, 2400. So where that comes from. And this times 1.73 will equal 4160 because of this. Because of this thing I explained to you, because of this, what's going on from B graph minus A graph, or it could be C minus A graph, or